MPLS TE multiple explicit tunnel. In this video, I am going to talk about the multiple explicit tunnel configuration and the usage of the multiple TE tunnel. Okay, the first question is that what is the usage of configuring of the multiple TE tunnel? Okay, let me to talk about this question in this scenario. As you can see in this scenario, we have 9 rotors from R1 to R9, and also in this scenario we are using the ISIS, but it's not important to using exactly ISIS. Maybe you want to use OSPF, it's okay, but let me to use ISIS as only one choice. And as you can see in this scenario, from rotor 1 to reaching the quad 7, we have 3 paths. Let me to write here. Look at here. From the rotor 1, we have 3 paths to the rotor 7. The first pass is rotor 1, okay, then rotor 2, then rotor 3, then rotor 7. And you know that the metric of this pass or cost of this pass in ISIS equal to the 40, 10, 10, 10, then again loop back 0, 10, 40, and this is the metric of this pass. Also, we have another pass from R1 to R6 to R7, and the metric of this pass, as you know, is 30. And also the next pass R1 to R4 to R5 and then to R7 has the metric of the again 40. And you know that the best pass is the pass with the lowest metric. Okay, because of that, if R1, okay, receives a traffic with the destination IP of the quad 7, okay, normally the R1 should forward to this packet to the rotor 6, because this is the best pass, and rotor 6 also should forward the packet to the rotor 7. This is the normal IP routing or normal forwarding, okay, you know it. And this is the normal behavior in the IP routing, that every and each router should first populate its routing table one with the routing protocols. After that, when a packet received by a router, the router should compare the destination IP of the packet with its routing table and finally forward the packet toward to the destination network. Okay, this is the normal behavior, but you know that here we have two other paths from R2 and from R4, okay, but we don't use them until the for example the pass from the rotor 6 failed. But if the pass from the rotor 6 is available, we don't use the for example top pass or bottom pass. This means that both of these two paths now are idle, okay, and we are wasting the bandwidth that we have. For example, if the R8 send traffic to destination of quad 7, the R1 should forward the packet from the rotor 6, and also R9 sending the traffic to destination of R7, again R1 should only forward the packet from rotor 6. This is the normal forwarding, okay? And in the IP routing, in most cases, you can't do any, for example, thing for solving this problem. You know that from R8 or from R9, we can't do anything for forwarding the packet in R1, okay? You know that if you are configuring other features of the IP routing in the R8, only R8 can be impacted, okay? And also R9, okay, but not R1. This means that in IP routing, we can say, hey, R1, please forward the packet from rotor 2. R8 can say to R1 that, hey, R1, please forward the packet from R2, or R9 says to R1 that please forward the packet from R4, okay, because R1 should for example take action, should forward the packet independently, okay. It needs to check its routing table, and after that it can forward the packet. R8 and R9 don't have any impact on the decision of the R1. This is a normal behavior. But with traffic engineering, we have some tools that we can conduct. We can, for example, forward the packet from the source. This is the source routing. Look at here. You know that because you learned about the TE tunnels, you know that I can configure a TE tunnel, okay, traffic engineering tunnel, for example, explicit TE tunnel from the router 8 to the router 1, and then to the router 2, and then to the router 3, after that to the router 7. This is the first tunnel that we can, for example, configure. And also we can configure another TE tunnel in the router 9, okay, router 9. And this tunnel started from router 9, then to the router 1, after that to the router 4, and after that to the router 5, and finally router 7. This means that from R8 we can forward the traffic to the R1, because this traffic is sent by the label of the, for example, first tunnel. The traffic can be forwarded to router 2. This means that we are using the source routing and the path identified in the source, and other routers should obey the for example the paths. Okay, this is the one of the function of the TE tunnels. In this scenario I am going to show you this usage, but about the configuration we don't experience any new feature. Because of that, this scenario is a practice about the configuration for us, and also here we can learn a technique to forward the packet, or better using from the bandwidth of the links. Okay, here we are practicing in this scenario, and also we are learning a technique to better using the, for example, bandwidth of the links. Let me to start the configuration of this scenario. I am going to configure the scenario from the scratch. You can for example, after configuration of the every part of the scenario, you can stop the video and configuring that part, and after that again watching the video, and then after again stop, and so on. Okay, let me to start the configuration of the router 1. It's so easy. Here we have instruction. We will go according to this instruction, but first we need to configure IP addressing. In this scenario I'm going to using one notepad file, as you can see, because we can configure easier and faster with the notepad file. Let me to start from the router 1, enconft, okay, interface hostname R1. You know that in the router 1 we need to configure hostname, and also in router 1, as you can see, we have 5 interface. Look at here. You can notice to my configuration method. With this method you can configure faster and faster interface ETH00, but I recommend for the first times you are configuring the new features manually, for example the TE configuration. But about the IP addressing, you can use the methods that we are using in this scenario with notepad file. Interface ETH00, this is this interface. We can configure the IP address as the 10.181, because this is the between router 1, this interface between router 1 and router 8, 255.255.255.0 and no shutdown. You know that here in this scenario we are using the ISIS. Because of that, let me to configure IP router ISIS, then ISIS for example network point to point. That's it. And then we can copy the configuration of ETH00 5 times, because we have 5 interface. This is the second, third, fourth, and fifth. Okay, we have interface ETH01, ETH02, okay, ETH03, and also ETH10. That's it. Now about the IP addressing, ETH01's IP address is 10.191/24, and other configuration are same. And also about the interface ETH02, we have the IP address of 10.121, okay, this interface, and other configuration are same. Interface ETH03 10.161, and other configuration are same. And after that, interface ETH10, the IP address is 10.141. That's it. As you can see, the configuration is easy and also is fast. Okay, this is the configuration of R1. Let me only configuring the ISIS also, router ISIS. Here we can configure the net address. As you can see in the first instruction of the scenario, configure ISIS in all routers and in all interface, we are using the area 49 quad 0 and also level 2 only routers. And this is the configuration. You learn about this configuration in the ISIS course. source, router ISIS, net address, IS type, metric style wide, log adjacency change all, and after that on the interfaces we can configure IP router ISIS and also ISIS network type point. Okay, let me